Good morning, student. Today again we are continue with the chapter continuity and differentiability. Today we will start with the question number 19 from the exercise 5.1. Let's start with the question. Show that the function defined by gx that is equal to x minus greatest integer function. Yes student, this is a greatest integer function is discontinuity at all integral point. Here greatest integer function that is less than or equal to x. This is given here. Now we have to solve it. So how can we do that? Let me start with it. All of you know about the greatest integer function. So here I am taking it limit x tends to n negative and I am taking it as a any integer number. For the left hand limit I am taking n here. If we will put it n here, it means that the value of n is little bit less than that value. So whenever we will put it here, it will become n minus 1. I hope that all of you know this. And if we will put x tends to n plus, and here if I will put down n plus, that will be equal to n. Let I will just explain you this one as like that. If the value of n is 2, if I am saying 2 minus, it means that the value of n is little bit less than 2. Like this, 1, 2. If I am saying little bit less than 2, when the function is the greatest integer function, the value will become 1. That means 1 we have to subtract here. In the similar way, if the value is greater than 2, little bit greater than 2, but the value of in the greatest integer function, that will be 2. I hope that all of you know this. All of you had done this in the class 11th. So here gx is given x minus greatest integer function. If I will write down in place of x n, then it will be a n minus greatest integer function n. Now we have to check that either the function is continuous or discontinuous. So for that I am taking here a left hand limit and the right hand limit. So how can I do that? First of all, I am taking left hand limit. So if I am taking left hand limit, then the limit x tends to n minus gx. Here I am putting down the values. Limit x tends to n minus x minus greatest integer function x. Here I am breaking down this limit x tends to n minus x, and then with the next minus sign, limit x tends to n minus again greatest integer function. At the starting we had done that the value of this is n minus 1 and the value of this will be n. All of you know that. So after solving that we get the value of this is as a 1. I hope that all of you get clear. So the left hand limit is 1. Now come on the right hand limit. Limit gx, again we will put down here gx x minus greatest integer function. Here we are taking right hand limit, so it will be a n plus. Again we break it into two part. We give the limit to this one and that one function. So here limit x tends to n plus x minus limit x tends to n plus greatest integer function n. As we had done this also, when there is a n positive, the value of this is equal to n. Now after solving that we get that is equal to 0. Now if we will see that the left hand limit that is not equal to right hand limit, as the left hand limit was 1 and the right hand limit was 0. So both of them are not equal. When both of them are not equal, it means that g is a discontinuous function at n and that belongs to an integer number. It is particularly for the integer number. I hope that all of you get clear this topic. Thank you student and have a nice day.